Hi, this is Rohan from educator.ai. Let's dive in. Welcome. In this video, we are going to dissect a prompt, the text you send to a large language model, an LLM. By the end, you will know exactly what a prompt is made of, so you can review a teammate's code and spot when a prompt is going to misbehave. Here is the situation you will hit as a developer. You ship a feature that calls a model, it works in your tests, then in production the answers get vague or inconsistent. To debug that, you need to understand what the model is really reacting to, and it is reacting to your prompt, token by token. Think of the model as a brilliant contractor with total amnesia. Every request they wake up fresh and know only what is written on the note you hand them. If the note is vague, the work is vague. If you forget the context, they cannot guess it. That note is your prompt, and it is the only thing steering them. Before anything happens, your text is chopped into tokens, chunks of characters, roughly a few per word. The model never sees letters or your intent. It sees this sequence of integer IDs. Everything the model does is built on these tokens, so a prompt is quite literally just a list of tokens. What does the model do with those tokens? It produces a probability distribution over the next token, how likely each possible token is to come next. Your prompt is the condition on that distribution. Change the prompt, and you reshape these bars. The whole reply is just this, repeated. Predict a token, append it, predict again. So the mechanism is a loop. Your prompt tokens go in, the model outputs probabilities, we pick one token, append it to the sequence, and feed it all back in. Because your prompt sits at the front of that sequence every step, it keeps steering every token that follows. This is the part developers trip on. The model has no memory between calls. Call 2 does not remember call 1. If you want it to know the earlier conversation, you must resend it inside the new prompt. Chat apps feel like memory only because they quietly resend the whole history each time. Now the anatomy itself. A well-built prompt has three parts that steer the model: an instruction, what task to do; context, the specific facts it should use; and examples, a demonstration of the output shape you want. Let us stack these one at a time and watch the output sharpen. Layer 1 is the instruction. A clear, specific directive summarized in one sentence narrows the probability distribution toward the tokens that satisfy it. Vague verbs like handle or process leave the model guessing, so be explicit about the task and any constraints. Layer 2 is context. The actual data the task needs, pasted right into the prompt. Without it, the model invents plausible-sounding details. That is a hallucination. With it, the answer is grounded in facts you supplied. This is the heart of retrieval-augmented generation, where you fetch relevant text and inject it before asking. Layer 3 is examples, showing one or two input-to-output pairs, sometimes called few-shot prompting. Examples pin down the format and tone far better than describing them in words. If you need strict JSON out, an example of that JSON is worth a paragraph of rules. Put them together, and this is your prompt. The crucial thing: instruction, context, examples, and the user's input all travel in a single call. There is no state to lean on. Everything in this box is what conditions the next token distribution. Nothing outside it exists to the model. Here is the mechanism made concrete. We encode each part of the prompt and count its tokens. Notice the context dominates, and because the model is stateless, you pay for all of these tokens on every single call. This is why unbounded context is a cost and latency bug waiting to happen in a pull request. Now the real thing. The system message holds the instruction, the user message carries the context. Temperature 0 makes token selection near deterministic, good for anything you want reproducible. When you review code like this, check: is the instruction clear? Is the untrusted email text kept separate from instructions? And is the output validated before use? The most common misconception is thinking the model is being random or forgetful on purpose. It is not. When a prompt is ambiguous, the model fills the gaps with whatever is statistically likely, and that shifts run to run. Inconsistent output is usually an underspecified prompt, not a broken model. Here is your review checklist. On the left, a prompt to approve. Specific instructions, context injected explicitly, user text clearly separated, so it cannot rewrite your instructions. That separation is your defense against prompt injection and output that gets validated. On the right, request changes, vague verbs, assumed memory, injectable input, and dumping the whole database as context with no bound on tokens. So 4 things to carry with you. A prompt is just tokens that condition the next token distribution. Instruction, context, and examples are how you steer it. The model has no memory, so resend everything each call and mind the token cost. And ambiguity in means inconsistency out. Review prompts with those in mind, and you will catch the bugs before they ship.